Hello again, it's Mr. LaBeouf, and in this video we're going to consider the two math concepts and vocabulary words, opposites and reciprocals. These are two concepts that are frequently confused, but this video will undo any of that confusion. It's very simple. Each concept is a very simple one. First, opposites. Two numbers are opposites if they are the same distance from zero. On the number line I've constructed here, I've chosen positive 2 and negative 2. They're both 2 units away from 0. They are opposites. All numbers on the number line, all real numbers, any real number will have an opposite. 0 itself is its own opposite because it is 0 units from 0. The number 1/2 and the number negative 1/2 are opposites. 1/2 is here. Negative 1/2 is here, and they are both 1/2 unit away from 0. In the future, you'll encounter the concept of absolute value. Absolute value is, again, a very simple concept. It means that the absolute value of a number is its distance from 0. So in terms of opposites, if two numbers are opposites, we can also say that they have the same absolute value because they're the same distance from 0. And one last thing we'll say about opposites is that two numbers that are opposites will add to 0. Let's take the 2 and the negative 2. Negative 2 plus 2 equals 0. For all real numbers, addition is commutative, whether you're talking about negative numbers or fractions. So that negative 2 plus 2 could also be written as 2 plus negative 2. And since addition is commutative, this has to be 0 as well. And the reason I mention this is that you might recognize 2 plus negative 2, except when you first encountered it in first grade or earlier, you didn't think of it as 2 plus negative 2. You thought of it as 2 minus 2. And of course, 2 minus 2 is still 0, whether we think of it in the subtraction form or in the form of 2 plus negative 2. When we formally talk about integer operations, adding, subtracting, multiplying, dividing whole numbers and their opposites, which are known as integers, one of the early things that we'll say is that when you add negative 2, it's the same as subtracting positive 2. We mentioned earlier that 0 is its own opposite. Well, 0 plus 0 is, of course, 0. So two numbers that are opposites will always add to 0. And that's it for opposites. Now we'll move on to the second vocabulary word or concept. And this second concept or vocabulary word is really the one that's relevant to this week's work. And that is the concept of a reciprocal. And the way that we'll define reciprocal is this. Two numbers A and B multiply to 1. If two numbers A and B multiply to 1, we call them reciprocals of each other. And if two numbers are reciprocals, they will multiply to 1. It's as simple as that. The first thing we want to observe about this definition of reciprocal, A times B equals 1, is that if either A or B is 0, then you cannot have this statement. 0 times anything is 0. So what that means is that the number 0 has no reciprocal because there is literally no real number that you can multiply 0 by to get 1. So 0 has no reciprocal. What about if A or B is 1? Well, let's say that A is 1. Then B would be 1. 1 times 1 is 1. So another thing we can say is that 1 is its own reciprocal. So 0 has no reciprocal, and 1 is its own reciprocal. Now, what about all the other fractions? We recognize a reciprocal of a fraction as being another fraction with the numerator and denominator in reverse position. Or in other words, flip the fraction. If you flip a fraction, you'll have its reciprocal. So let's take an example of 2/3. Let's consider what is the reciprocal of 2/3. Well, if you multiply 2/3 by 3/2, multiplying across the top and bottom, we would have 6/6 or 1. So the numbers 2/3 and 3/2 are reciprocals of each other because they multiply to 1. And notice visually, one is the flipped version of the other. What about a whole number? What about a number like 6? What is the reciprocal of 6? You might want to think about this, or pause the video and think about it. 6 times what equals 1? Well, when we're dealing with fractions, a whole number is a fraction. We can make it look like a fraction by putting a 1 under it. So if you were stuck as to what is the reciprocal of 6, if you think of the 6 as 6 over 1, and think about that concept of flipping, well, you might come to the conclusion that the reciprocal of 6 is 1/6, and you'd be right. If you multiply across the top and bottom here, you'd have 6/6 or 1. And finally, let's consider a mixed number. Would you like to think of a mixed number? 2 3/4. I bet you were thinking of that one, weren't you? Well, what do we multiply 2 3/4 by to get 1? And very often when we're dealing with fractions and we encounter a mixed number, we need to think of it as an improper fraction, as a single fraction. If we think of the 2 3/4 as a single fraction, then this question is easy. 2 3/4 is, of course, 11/4. By now, that should be easy for you. You should be able to convert any mixed number to an improper fraction or vice versa. So what do you multiply 11/4 by to get 1? Well, 4/11. And again, two fractions are reciprocals of each other if the numerator and denominator are in reverse position, or if you flip one of them, you'll have its reciprocal. We put a 4 and an 11 there. Multiplying across the top and bottom, we get 44 over 44, which is 1. So the reciprocal of 2 3/4 is 4/11. Bye-bye for now.